All right, so let's see how we did. So the domain, we can certainly plug in any number that's greater than or equal to -2, right? Because we're either using this, or this rule, and these are always defined. So the domain of f would be all x greater than or equal to -2, or as an interval notation, this would be -2 to infinity. The x-intercepts, that's when we find where f of x equals 0. Now we have three different rules, and we have to find out where each of these are 0. But we also have to make sure that they agree with these cases here. So, for example, if we said x plus 3 equals 0, obviously we get x equals -3 for this. But the problem is -3 is not in this range. Okay, so that, and we already know it's not in the domain, so we don't get anything there. Likewise, 5 can never equal 0, right? So we don't get anything there. And then if we set minus x plus 2 equals 0, well, we get x equals 2. And that is in here. The 2 is bigger than 1, right? So that's our x-intercept. So our only x-intercept would be at 2. Okay. For the y-intercept, that's always just whatever f of 0 is, which we know that when x equals 0, 0 is between -2 and 1, so we use this rule, so this would be 0 plus 3, which is 3. So y equals 3 would be the intercept there. Okay, so to find the graph of f, I think again we can sort of see what's going to be happening. We're going to get these lines, like two lines and an isolated point, maybe. But if again, since we're doing it for the first time, let's plot a few points and see what's going on. Okay, so you can start at -2, -1, 0, 1, 2, 3, 4, and so on. We already said that when x equals -2, we use this rule. So -2 plus 3, that's 1. -1 plus 3, that is going to be 2. And when x equals 0, we get 3. That's our y-intercept. Okay. When x equals 1, the output is 5. When x equals 2, when x equals 2, we said that's our intercept, so that's 0. And then when x equals 3, we use this rule. -3 plus 2 is -1. When plug in x equals 4, we get -2. Okay, so we can plot these points. And then hopefully you can see that all these points are going to lie on one line. These 3 points lie on this line that goes all the way up to 1, because at 1 it changes rules, so we have an open circle there. And these points are all on the graph of, these are on another line, namely the line given by y equals minus x plus 2. Okay, and that goes all the way up to about here. Okay, so that's what the graph of f of x will look like here. Okay, and again, this is so we have that now. This continues. This does not, because this starts at -2. Okay, so again, this is the graph of y equals x plus 3. This is the line y equals minus x plus 2, and we have pieces of these graphs. And that's why they're called piecewise defined functions.